Your MCP client needs a FastMCP server configuration, but you don't want to manually write JSON for every environment or client. We'll see how to generate standardized MCP JSON configurations directly from your server code, with full control over naming, dependencies, and environment variables, all in a single command.
#useServer's built-in name from FastMCP constructor. FastMCP install MCP JSON server. Hi. #override with custom name. FastMCP install MCP JSON server. Hi name custom server name.
This demonstrates the configuration as code pattern for server deployment, where infrastructure setup is defined through declarative specifications rather than imperative scripts. The approach generates standardized MCP JSON configurations that encapsulate all runtime requirements, command structure, dependencies, and environment variables in a portable, client-agnostic format. What distinguishes this pattern is its ability to bridge the gap between development environments and production systems through a single, version-controllable artifact. The pattern works by externalizing server configuration into a structured schema that separates concerns. The code defines what the server does, while the configuration defines how it runs. FastMCP acts as the translator, converting high-level directives, like with Pandas or Python 3.11, into executable commands with proper dependency isolation and environment setup. This declarative approach ensures consistency across environments, as the same configuration can be consumed by IDE integrations, CI/CD pipelines, or custom tooling without modification. This matters because it solves the works on my machine problem at scale. By codifying server requirements in a standardized format, teams eliminate manual setup steps and reduce deployment friction. The trade-off is a slight initial learning curve for the configuration schema, but the payoff comes in reproducibility, whether you're sharing configurations with teammates, deploying to cloud environments, or integrating with third-party MCP clients. It's particularly valuable in AI workflows, where environment consistency directly impacts model behavior and tool reliability. Let's break it down line by line.
#useServer's built-in name from FastMCP constructor. FastMCP install MCP JSON server. Hi.
This installs the MCP JSON plugin using the server's default name derived from the FastMCP constructor. Default naming simplifies deployment when custom identification isn't required, ensuring consistent behavior across environments without manual configuration.
#override with custom name. FastMCP install MCP JSON server. Hi name custom server name.
This overrides the default server name during installation, allowing custom identification in FastMCP's service registry. Critical for environments with multiple server instances, where meaningful names simplify monitoring and debugging. The name flag follows FastMCP's standard CLI pattern for runtime configuration. FastMCP configuration flexibility. The MCP JSON installer bridges Python servers and MCP clients by generating protocol-compliant configurations, supporting everything from simple CLI overrides to declarative FastMCP JSON manifests. Environment variables and dependencies specified during installation become invisible yet foundational, silently shaping every client interaction. A single configuration file can replace dozens of CLI flags, making complex deployments reproducible.
The configuration that disappears becomes the protocol that connects everything.